Okay, so I built several models to do several visual tasks, including alt text generation through image caption generation by uploading an image and having the model produce alt text, video action recognition to test the output of videos and to verify what actions are occurring in the videos, and also visual question answering, so you can interrogate an image and ask what's happening within the context of an image. All of these models are cross-modal transformer-based models. They're models that I are essentially open source, that I helped build some of it from the ground up. I'm not using any APIs or DALLs or large pre-built large language models or anything like that, but as you'll see, they still have comparative performance, and the only cost of them is actually running the model, which can be done locally and on device. So here is an example. So the service is, so this is a client, just a simple UX that I've written to interact with my backend Python Flask service for each of these functions. So let's say I choose a file, and I will choose an image file, and I will pick some image that has information, a good deal of information in it. And so let's generate a caption. And as you can see, a couple walking down the street holding balloons. There's no meta in this image, by the way. This is just literally a screenshot that I took. The machine learning model is actually learning what's happening within the image and then outputting a caption. If I choose another caption, let's say it's of a person that's well known, because of the pre-training, it knows that this is Lady Gaga. If I choose, let's say, this portrait of the Mona Lisa, funny, sometimes all this repeated captioning comes out, but that can be tailored. Let's say I choose another picture with some context, upload that, describes it pretty well, a woman sitting in the woods with her phone. And if I pick objects to, the caption can determine a lot more complicated context. So bear and tiger are in the wild. Again, being able to identify not just an image, but what's happening within an image. So let's try, and let's try maybe one more for good measure. So objects within a scene, a desk with a notebook and a pen again on it. So again, no meta is here. It can understand image placement and image context simultaneously altogether, and we can also pre-train this model and make it much more specific to images and alt text that we want to output in a particular style or in a particular manner. So for the video action recognition model, let's say I pick a video, and this is, again, is all done locally. There's no API calls or anything like that. This is all on device. I upload an image and a video, I upload a video, and as you can see, it can detect actions that are occurring within the video. It's person's playing soccer, and then there's a probability of what action is occurring. One thing I would like to note is that the model is actually pretty powerful. I can build this example, I don't have it in it, but if there's multiple things happening within a video, the model can actually do segmentation. And so you can see the model can get as granular as knowing exactly what type of stroke it thinks this person is using, a breaststroke, butterfly stroke, and there's lower probabilities of other actions, but it can detect this person is swimming. Essentially, if multiple things were happening in the video, the model could be built to output separate probabilities per segment, so you can see several things happening simultaneously. And here's another example of a person, two people performing an action, and the model clearly knows that this action is tennis, and it persists to be tennis throughout the good deal of the video. So, and that's video recognition models using inflated convolutional neural nets trained on the Kinetics 500 data set. Very powerful tool, which we can do a lot with, potentially. And let's finally look at visual question answering. So visual question answering is, if I'm given an image, we can ask questions about what's going on in an image. So I'll upload the same image. Again, there's no context in terms of meta within the image itself. This is just a screen capture. And my tool is set up. I built the UX so it can keep asking questions. What color are the balloons in the image? So pink, right? What is the road made out of in the image? Cobblestone. So you can see it gets very specific in what you can ask and interrogate from the model. And there are firearms in the image. No, and so as you can see that it doesn't suffer from issues with interrogating on very specific questions because this is a baseline model, transformer model. It doesn't have any additional guardrails or anything, but those can be built on top if necessary. And so, yeah, I just wanted to demonstrate some of the capabilities available with this on-device small model learning and inference. And the inference time is actually very fast because it's on device and no API calls, no cost for setting up an API or anything like that. This is all can be built on in local infrastructure, and it can perform very well. Thank you.